Hello, you are welcome to today's class. In today's class, we are going to learn about implicit differentiation. Now, one thing you need to know about implicit differentiation is that it is a type of differentiation whereby you differentiate two functions, that is both the x and the y at the same time, okay? So if you are differentiating an implicit differentiation, you differentiate both x and y at the same time. But anytime you differentiate a y function, you write dy dx at the front of it, okay? So you differentiate both x and y, but whenever you differentiate the y variable, you write dy dx at the front of it. So let's use this one as an example so that you understand more what I'm trying to say. So if we are to differentiate this one implicitly, that is implicit differentiation, we'll start by this one. So if we are differentiating this one first, now we have like this one, we have x and we have y. So first we are going to start by differentiating the x variable. So if we differentiate x, we know that the power is going to come down. So 2 is going to come down, multiply by this 4 is going to become 8. So we are going to have 8, then x. Then we'll subtract 1 from the power, which is 2 minus 1, and it's going to become just 1. So there's no need of writing power of 1. You can just write it as 8x, then multiply by this y that is here. So I have y. Okay. Now the next thing I want to do again is to differentiate this y. Remember, I only differentiated x, so I'm also going to differentiate this y variable. So, but firstly, I'm going to write my plus. Since this one is constant now, I'm going to keep this one constant, which is 4x squared. So if I differentiate y, you know it's going to become 1. If you differentiate y, the answer is 1. So now, because I differentiate with respect to y variable now, I'm going to put dy dx. Is that understood? Remember, I told you anytime you are differentiating a y variable, then you put dy dx. So I'm going to move to the next one, which is plus 4y. Now I'm going to differentiate 4y again. If I differentiate 4y, it's just going to become 4. Okay, so this is just going to be 4. But because I differentiated with respect to y, I'm going to also put dy dx. Understood? Next we move to the next one, plus. Now here we also have two variables, which is x and y. So first I'm going to start with the x variable. So if I differentiate x to the power of 3, I'm going to bring down the power. If I bring down the power, which is 3, it's going to be 2 multiplied by 3, and that's going to be 6. Okay, then we'll write the x, then we'll subtract 1 from the power. So 3 minus 1 is going to become 2. That's 6x to the power of 2, then multiply by this y function, which is y to the power of 2. Then I will also write plus again. So now I differentiated with respect to x the first time, so now I'm going to differentiate with respect to y. So now I'm also going to, if you are differentiate y to the power of 2, you know I'm going to bring down the power down, which is 2, bring down 2. Okay, write down 2, and then subtract 1 from the power. We write the y, then subtract 1 from the power. 2 minus 1 is going to become 1. So then I have this one, which is 2x multiplied by 2x to the power of 3. Okay, so because I differentiate with respect to a y variable, I'm going to write dy dx. So from here, the next thing I'm going to do is to differentiate this one now. So we'll say equals to, now we are going to differentiate 12x. If we differentiate 12x, you know if we differentiate x, the answer is going to be 1. So what we've left here is just going to be 12. So we'll have 12 here. So again, one thing I need you to know, if we look at this place, we have 2y, then 2x to the power of 3. Instead of writing as 2y, 2x to the power of 3, we can multiply these 2. If we multiply 2 times 3, it's going to give us 4. So we can write this one in such a way that instead of writing them separately, we can write as just 4y, then x to the power of 3 dy dx. Is that understood? Alright. So what we want to do from here is to collect like terms. How do we collect like terms now? We collect like terms by grouping those ones that don't have this dy dx on one side, while those that have dy dx will carry it to one side. Is that understood? So now if we look at the equation, you can see that like this one, and then this one, and then 12 here, all of them don't have dy dx, so we can keep them in this side of the equation, while the other ones we can transfer them back to the other side of the equation. So let us do that together. Now if we do that, we are going to have 8xy. So the next one that don't have dy dx is this one, which is plus 6 square y square. So I'm going to bring this 12 to this side. If I bring this 12 to the other side of the equation, the sign is going to change and become minus 12. So we now see it's equals to, so I'm going to transfer all these ones with the y to the other side. So if I do that, I'm going to have minus, the sign is going to change now and become minus 4x squared, that is dy dx, and then plus 4 dy dx, and then we'll have minus, sorry, this is minus here because you know it was plus, so it's going to be minus, and then this one will have also minus 4y x cubed dy dx. Alright, so now we have collected like terms together. What we want to do next here from here is to factor out the common term between these ones. So this one you can see that all of them have dy dx, dy dx, dy dx. So what I want to do next is factor out the common term, which is dy dx, okay? So we are going to have 8xy plus 6 minus 12 equals to, so if I factor out dy dx from here, I'll have that dy dx open bracket. So what will be left here, if I remove this one now, what will be left here is just 4x squared, okay, minus, if I remove dy dx, what will be left here is just 4, and then if I also remove dy dx here, what will be left here is just, sorry, be minus 4yx to the power of 3, and that's what is going to be left here. So what I want to do next from here is to divide both sides by this this what is in the bracket, so that I will make dy dx of the formula. So I want to make dy dx the formula. So if I want to do that, to achieve that, I will divide both sides by what is entirely in this bracket, okay? So if I do it, I will say all over, so we'll have 4x squared minus 4 minus 4y x to the power of 3. This side I will also divide everything here by 4x squared minus 4 minus 4y x to the power of 3. So that means this one now we're going to cancel this one, and so what will be left is dy dx is equals to 8xy plus 6y squared minus 12 all over 4x minus 4 minus 4y x to the power of 3. So this is the final answer to this question, and that's how you carry out implicit differentiation.